Right. Okay, so this is like what I'm working on.
Okay. So this is just to be clear, your mom said we're going to do something on microeconomics. Is that also going to happen, or is it just the math you want to work on today? Doesn't matter to me. It does not
No,
matter to me.
I already finished my economics.
Perfect. Okay. So
So
here,
yeah, we'll be good with that.
okay. So here is my here's how we're going to do this. I'm going to snip each question and then share my screen. Okay. So it's kind of a little bit of like back and forth. Each time, unfortunately, some mouse clicks, then you have to share your screen and we repeat. But
Oh
it
no,
will
that's fine. I was thinking that anyways.
it will get done doing this way. So if you're seeing my screen, you see question number 1. Do you see that? Are you seeing my screen now, Jayla?
Yes.
Okay. All right, so let's work through this. The first step for undoing log base 5 is to raise both sides using a base of 5. So on the left, this just cancels out the log base 5. So I'm trying to get to where I can show this with a color. Those cancel, and then you're left with 5x plus 10 equals 5 to the power of 4. 5 to the power of 4 is 1225. We'll subtract 10 from both sides. So 5x equals 1215. Divide both sides by 5, and you'll have your final answer there. So go ahead and check these along the way, because usually these automated systems, you have to make sure that you're doing the right thing for it, or you have to put the right answer in, or you don't get any credit, as you know. But what I get here is 243.
Okay, Rick.
No, this is wrong. This is 625, not no. It's 5 to the power of 4. Sorry, I don't have a calculator handy. Let me go grab one.
No, it's okay.
5 to the 4th. Yeah, 625. Not 1225. Okay. We'll subtract 10, and then we'll divide by 5. So 615 divided by 5. And final answer of 123. It does look like that email came in.
Okay.
So maybe this will be a little smoother here. All right, so let me see. Email is loading. Okay, there it is. All right, do you want to do the screen sharing back and forth, or do you want me to try to use these images? Actually, they're hard to...
You can use the images. It doesn't matter.
Actually, unfortunately, the way they came in, they're too small. Let me try. Yeah, the file says they're too small. So you'll have to share your screen for each question or retake.
Okay, that's fine. Okay.
All right, so as you're sharing your screen, grab this question here, question number 3. So question 2 was clear how to do. Is that right?
Yeah, I already know how to do question 2. I got all those ones done except these ones.
Perfect. Okay, I'm going to share my screen now. So if you're seeing my screen, you see the problem here. And this time you have the log of something equals the log of something. So you set the inside parts equal. 12x minus 9 equal to 3x. And then you just solve for x. So you subtract 3x from both sides, add 9 to both sides. So you get 9x equals 9, divide by 9. So x equals 1. And then if you check that, 12 times 1 minus 9 is 3. 3 times 1 is 3. So it does work there. So the key, though, is when you have the log of something equals the log of something, you set them equal to each other.
Yes.
All right, this looks like you're sharing your screen again. Yeah, so this one's really similar to the last one. I'll grab it, snip it in. We are going to set the part inside the log equal to each other, but let me share my screen so you can see that. All right, so if you're seeing my screen again, like they don't write the parentheses around the 6x, but they should. You set 5x plus 9 equal to 6x. And then this time when you subtract 5x from both sides, you get 9 equals x. And that's your final answer. Now we can check that. 5 times 9 plus 9, that's 54. And then 6 times 9 is also 54. So you can see how those are the same.
Mm-hmm.
All right. Will you pull up the next question? I'll snip it, but I'm going to mute myself just for about 1 minute, if that's okay with you.
Okay. No, that's fine.
I'll say hi when I'm back. Thank you.
Okay. Yeah.
All right, I'm back. I did go ahead and grab that next question, I believe.
I actually just got past that one.
Oh, you did? Okay, great. Let's
Yeah, I'm on to the next one.
let me snip in number 7. These in some ways are actually getting easier than the first one. They must just do them in a random order. So I'll share my screen and work through this one. So even though it doesn't show it, this 38 is really in parentheses. So you just set them equal to each other. 7x plus 3 equals 38. Subtract 3 from both sides. 7x equals 35. Divide by 7. So x equals 5. And if you check that on the left, obviously 7 times 5 plus 3 equals 38. So it does work out the way we expect.
I'm actually on number 8. I'm getting the hang of these.
Great.
But I got a fraction on this one.
Let me get back to your window.
Yeah.
Oh, you're not sharing it. Okay.
That's what I got for this one.
Okay, yeah. So this one is slightly different. 2 to the 5th is 32. Yeah, let me slip this one in. This is the type where it's the log equals a number, and there's just an additional step here. So let me share my screen so you can see me work through that. Okay, so if you're seeing my screen, notice this is the type log of something equals a number. So in this case, you need to undo the log base 2. So you would write 2 as a base here and 2 as a base here. So whatever number that is, these have to match. On the left, it's 4x plus 8 equals 2 to the 5th. 2 to the 5th is 32. Okay, and then you subtract 8 from both sides. 4x equals 24. divide by 4, and x equals 6.
Okay, I'm just gonna write this down so I know how to do these.
Yeah, and I'll send you this as a PDF at the end also, but yeah, go ahead and write it down if you've got the time now for that.
Yes. Okay. I was completely off on that one.
Well, yeah, it looks kind of the same, but that additional step changes
Yeah.
all the numbers, and then you're like, yeah, you know,
Oh.
and it worked. I think you wrote -3/4, and it kind of looked okay. So you're like, well, it kind of
Yeah.
works, right?
Right, because some of them take fractions, but then some of them don't. That's why math is like so confusing sometimes.
Yeah, but your mom said you're just trying to get to graduate here, and that's my
Yeah.
goal in helping you, is to make sure that we get through this, and you can deal with math another day.
Right.
All right, let me share
Hopefully
my.
nothing like this.
Right. Do you know where you're going to college, or do you know what you're doing after high school?
Yeah, I'm actually going to be going to Carrington Medical Assisting School after. I just got to take a like 30 question test in like 8 minutes, and I got to answer like as many
Yeah.
questions, and that'll determine if I like get into the school or not. But
Great.
yeah.
Great. Well, let's do this so that you can get through high school, and then you can move on to that. So
Right.
so again here, see how 3 is the base on both
Mhm.
sides here. Let me just rewrite it. On both sides of the equation, you have to share. You have to say, okay, I'm gonna put a 3 there and a 3 there. And on the left, it just becomes 2x plus 1. These cancel. On the right, it's 3 squared. Be careful how you answer that. It's 3 times 3, which is 9. 2x plus 1 equals 9. Subtract 1 from both sides. 2x equals 8. Divide by 2. X equals 4. So once you undo the log or undo the exponential, usually it gets down to something you already know how to solve.
Right. Okay. Cool. This is actually really easy.
Yeah, sometimes just seeing a few guided examples really helps you to do that. But we can work through as many together as you want, or you can work through some on your own. It's totally up to you.
I actually just got the last one.
Perfect.
And yep, that's correct. Cool. Now I'll go over to my other assignment.
Okay, I will stand by. I think this is working here with the screen sharing, so just you can share with me when you're ready.
Sounds good. And also, I didn't do too well. I passed my test, but I didn't do too well on it. So I'm gonna go in and retake it tomorrow or
Great.
after spring break.
Okay.
So, but I did get my chapter 6 quiz. I got an 11 out of 15 on it instead of an 8 out of 15 on it.
Okay.
So that's good.
Well, I'm sure your mom just wants to see some improvement, and you still have a little bit of time before the end of the year. So just if you can show a trajectory that, hey, I'm getting better, I'm getting the help I need. She said you're doing great when you were getting some regular help. So I hope I can continue doing that for you. All right.
I hope so too.
So we'll start with this one, Jayla. Okay. Let me snip it in here. All right. So I'll share my screen. Okay, so there's a property of logarithms, which when you're adding right here, you can make this into a product. So the natural log of A plus the natural log of B becomes the natural log of A times B. So essentially, you're going to multiply the X and the X minus 2, okay, equals 5. See how I just multiplied those together here inside the one natural logarithm.
Mm.
Maybe. Okay, let's try this another way.
Okay.
Because this way isn't maybe all that effective. So I'm going to share a different screen and we're going to graph it.
Okay. Can I use Desmos on these?
That's exactly what I'm going to do here. So let me show you one,
Awesome.
just since we're doing a lesson here, and then you can decide if you need more than that. But I just type in exactly what is written, okay. And then instead of putting equals 5, I'm going to write y equals 5.
Okay.
And then in the previous one, you can write y equals. And what we're essentially doing is figuring out where do they intersect, and they intersect right there at 13.22. So basically each side of the equal sign is an entry into Desmos for this.
Okay. Sorry.
So I'm going to snip this back into our shared space. There it is. All right. And you can go ahead and share whenever you're ready the next question you want us to work on.
Okay. Wait, the answer would be 13.233, right?
I got it said to the nearest hundredth, which is 2 decimal places. So that 3 rounds down to the 2.
Okay. So it'd be 1.22?
No, 13.22.
13.22.
Yes. I mean, do you see
oh,
that?
the other thing. Okay.
Yeah, you see that's where they intersect here is 13.22.
Right. Okay. Okay.
Yeah, so again, this one, I'm going to do it off to the side here also, but you can put in log base 2 into Desmos of the x squared minus x minus 6. And then in your line 2, you can write y equals 2. And you can show where they intersect here. So I was able to get that up for you. That one come in here. Let me share my screen so you can see that. Here we go. Just resize the window. So again, like that left side of the equation, I made it a base 2. And if you're not sure how to do that, you go down to the keyboard, and somewhere in here is a subscript. You can also use keyboard commands. Anyway, and then the right side is 2. Excuse me. So just figure out where they intersect, and you want the x values.
Okay.
So minus 2.70 and then 3.70. Because it's asking for numerical approximations, this method is totally okay. Like if it was a nice number, we would do it by factoring or maybe completing the square or quadratic formula. But because it wants you to round your answer, that's why this method is okay. We'd either be going to your graphing calculator or doing this.
Okay. What are they supposed to round up to? They're supposed to round up to like a 1?
What does it say in the problem? I didn't snip it. How many does it say to the nearest hundredth?
Nearest tenth.
Okay, so nearest tenth in this case would
Or would it
be
just be negative 7.2?
negative 2.7. And then the other one is 3.7. And sometimes they want you to do them in a certain order. So just pay attention to like whether it's the smallest one first.
I'll share my screen.
All right. So for this one, would you be willing to graph it on Desmos on your side?
Yeah.
Okay. Let me just grab a quick snip of it so I can see it while you're doing that. All right, go ahead, please.
Okay.
I'll talk you through it also. It's that, yeah, that second one is perfect. Okay, so type in log, L-O-G, and then underscore. Underscore is usually like the shift hyphen, and then the 2. And then go to the right. So hit the right arrow on your, or just click, yep, X plus. And then log base 2 again. This time parentheses when you go to the right. X minus 2. Okay, and then go to the next line. So you either click there or hit enter. We want to go down to the next row. There you go. And then type y equals 3. Okay, and then where do they intersect? So this one was a nice value. Like we could have done this by hand.
Right.
So maybe for the next one, I'll show you how to do it by hand, but seems to be okay doing it this way.
Oh, this is like the same one.
Yes. So you have a choice here. Do you want us to do these by hand or use the graphing calculator?
I mean, honestly, I'll probably just use the graphing calculator for anything that I can use the graphing calculator for.
So I'm gonna snip in this one into my screen, but if you go ahead and go back to your Desmos and see if you can enter this one and work it out.
Okay, let me just write this down really quickly. X. So I just don't forget. Okay. Okay. I'm ready.
All right, so go to your Desmos and go ahead and enter the left side of the first one. So I see log base 6. And then parentheses 3x. Close parentheses. Plus log base 6. Okay, and then open parentheses, x minus 1. Perfect. Go to the next line and type y equals 3. You can see that looks like it's another nice point. It's exactly at 9, which means we could do it by hand if we need to.
Cool.
Okay, can we skip past these, or do you have to do them in order?
Yeah, no, we can skip past these.
No. Let's go to 6. 6 is a little bit different.
6. Okay.
Yeah, let's go to 6. So let me show you how to do this problem. This was actually on one of those quiz questions that we had looked at last time. So share my screen and we'll take a look here. All right, so if you were to graph the log base 4 of x, it looks something like this, and then 4 hits it here. Okay, so we're looking for that point. We're literally looking for where do they intersect. Okay, so to solve this, you go, okay, where is log base 4 of x equal to 4? And we did this in the previous problem. Use 4 as a base on both sides. It cancels out, and x is equal to 4 to the power of 4. Okay, so 4 to the power of 4. I'm gonna say it's 216, but I messed that up really badly earlier. So let me check that. It's 256. Okay, so the answer is, like, if we go back to our picture, the answer is 256. So you might think it's all the numbers less than 256. Okay, but
Right.
here's the thing, log is only defined when it's greater than 0. So the solution is x is from 0 all the way to 256 because it can't go negative. That's just not allowed in these problems.
Right.
Okay, so I think this is the way your thing will let you enter it. It could also be an interval notation, 0 to 256 with parentheses. Do you remember what it tends to accept?
Yeah, no, it'll accept this because it has the greater than or equal to sign and less
Okay.
than sign.
Perfect.
X256. Cool.
Okay, so once you share your screen and we'll look at number 7. Okay. All right. So this one, again, is a little bit more challenging. How do I want you to do this? I guess I'll show you how to do this by graphing, and then but the reason I can't just say, okay, here, go and use Desmos is you have to, you literally have to like interpret the answer. So let me share my screen, and you've still got that up on your side, but the what we're going to do here is we're going to set them equal to each other again. So the right side, or the first line, is 3 to the 4x minus 5 power, and see how it's this growth. It's this thing that's growing up pretty steeply. And then the next one is y equals 8. Okay, so if I zoom out a little bit, I got to figure out where do they intersect. So they intersect here at 0.584. And when it's this thousandth, that's the that's 3 decimal places. 0.584 means we got to include all of them. So it's nice that Desmos already includes that. Now, I told you before that logarithms were only good past 0, but this is not a logarithm. This is an exponential. Oops, I graphed this incorrectly. Okay, it's 4x minus 5 in the exponent there. So all that does is change the number that we grab here. So it's actually 1.723 where they intersect. Okay, so in terms of what you're going to answer here, let me go back to the other screen. In terms of what you're going to answer, it's all the numbers less than 1.723, because that exponential has that graph, and then it's hit at 8 right there. It's everything to the left of it. So it's all the numbers left in that, but we're not restricted with the 0 like we were in the previous problem.
Okay. Wait, sorry, it was 1 point what?
723. But x is less than that. Are you seeing my screen, or are you seeing the graph?
Yeah, no, never mind. I got it.
Okay, great. Yeah, that's one of the things about this format. It's sometimes it's I say something and you don't see it, or you see something anyway.
Right.
All right.
Okay, I'll share my screen for this one.
Yep. All right. So this time, let me take a snip, but I want you to go to Desmos, and I want you to enter these in to the left and the right side. So I've got it down here. If you want to go open your Desmos, I'll talk you through it. So 4 to the power of x, 4 caret x, or exponent x.
Okay.
And then the next one is next line will be y equals 36. Okay, so that line is way up there, so you have to zoom out. You can either scroll, or you can use that minus symbol on the right. And you're almost there. There it is, boom. Okay, so we want to, and so what I like to do is click on it and then just zoom in. And to that point, like scroll, if you have a mouse wheel. Okay. All right, well, that didn't work great. Let's, and remember, you can, there you go. So it's 2.585. Okay, so you got to remember that number. Let's go back. So it's 2.585.
Mm-hmm.
So we're going to write that number into that box there.
Oh.
But this time, it's all the numbers that are less than or equal to that. So you gotta go back to the beginning of the box there. And yeah, right before the 2, and put an X. But this time it's X less than or equal to. So it's not, yeah, there must be some more advanced ones. They're there, that one there. And it's because of that symbol that's in the actual problem.
Right. Okay.
Okay, so we'll do the same thing on this one. Go ahead and go back to your Desmos. So the first one, type in natural log of X. Okay, and then I think the next one was, it was 3y equals 3. Okay, and then figure out where they intersect. So we need that number right there, 20.086. So you have to remember that.
Okay.
And we want to go put that in the box.
Okay.
So this time you want all the numbers to the right of that. You always put the variable on the left side though. So you want to go back to before the 20 and put an X there. And you almost always use the same symbol that's in the problem.
Yes.
Okay.
Okay.
So I think we didn't do 6 or 10 in this set, but why don't we just do those? Why don't we do 10 and you try 10 here on your own, or go back to the Desmos and we'll do it together. But
Okay.
so it's y equals, I'm sorry, it's just 9 to the x. Exponent.
Okay.
And then I've already forgotten the other number.
54.
54. We got it. Okay. So y equals 54.
Oh.
Now you might ask yourself or say, hey, Matthew, why don't we put a y in the first one? We actually should, but it seems to work without it. So that's why we haven't been doing that.
Okay.
1.815. Perfect. You got it. So that's the number. And if you go back to look at it's going to be x greater than 1.815. But it's just greater than, not a greater than or equal to, yeah. Because of,
is that greater than?
Yes, you got it.
Cool.
Okay, let's go back to do 6.
Or
whichever. This one right here. Okay.
Yeah.
Okay, let me grab a snip of this or I will not remember, and I'll talk you through it. Okay, go ahead. Go over to Desmos. Okay, so in line 1, you're going to type natural log of x, or ln x, plus natural log parentheses x plus 3. And then the next line, this is where you put the other side of the equal sign. So go down to the next line and type y equals 4. Okay. And this time you just want to figure out where they intersect. You just need that value rounded to 2 decimal places. Looks like it's 6.04.
Okay. Yay.
Right.
Well done. Coolio.
So remind me, you want to do 2 assignments, or 4, that we want to get done 4 assignments. Is that right?
Yeah.
Okay.
And we just have like 2 left, so we'll probably finish around like probably like 1:30. I'm thinking.
Yeah, I
So it
do.
might not be like full 2 hours.
We're gonna stop at, so the lessons go for 50 minutes. We're gonna do another 7 minutes here, and then we'll take a short break. Okay.
Okay.
I need it, and you may or may not need it, but it's usually good for everyone. So let me snip this one in.
Yeah.
The last ones, I mean, you get maybe think, well, I don't just use Desmos for everything, but
Yeah, right?
but
That's what my teacher honestly tells us to do because he's with us like he's really smart, but I think he knows that Algebra 2 just sucks.
well, he's hopefully he's telling you that there's always a tool to do the job, make the job easier.
Yeah, no, definitely. He's better than my other teachers that I had. He wanted us to write everything out on paper.
Right.
And his whole class is failing.
All right. So this one, this one is a recipe. These are inverse variation problems, and the sequence is you first write out the inverse variation formula, which is k over x, and they give you x equals 3. Okay, they give you these 2 points. This is written in a common odd order. So you substitute these in for x and y. So y is minus 5 over 4 equals k over negative 4. And you have to solve for k. Okay, so this is a little bit more involved than the last set of problems. To solve for k, you can cross multiply here. Do you remember doing that at some point?
Yeah.
Okay. The other option is to just clear the negative 4, but we're going to cross multiply here. Sometimes this is called a butterfly. So negative 5 times negative 4.
The k equals 5.
And yeah, 4k and k equals 5. Perfect. Now, you did that really fast, which is awesome. The first thing you need to do here is you rewrite the equation with the k. So it's 5 divided by x. That's this first box here.
Okay. Okay.
The next thing you do is you
plug it in.
You plug it in. Like in this case, you just have to plug that x value in there. So this box is 5 divided by 3. So you solve for
that's
k.
really easy.
It's not bad. You write the equation and then you use the equation.
Great. Okay.
And go ahead and share the next problem whenever you're ready, and we'll take a look at it.
Okay. Yeah, I just got this new chapter yesterday, and it's different.
Okay, this one we're actually going to do visually.
Okay.
Well, actually, no. I'm sorry. I do need to
I'll
just.
have notes on this. Would it be an inverse?
It has the visual appearance of that, but let me just snip it in and just tell you the 2 possibilities that you might be thinking. Okay, so I didn't do this in the last problem, but there's direct variation, which is y equals kx, and then there's inverse variation, which is y equals k over x. In both cases, you need to solve for y. So you solve for y here by multiplying both sides by x. Y equals 8x. So which one does this look like? Is it direct variation?
Like direct, yeah.
So you can't answer the question until you solve for y, but it has the appearance of maybe being in one or the other.
Yeah. Okay. Cool. Oh, I hate doing this. Oh.
Okay.
So I know how to do this, but is there like a faster way that I could do these?
Yes.
Or
Multiply the x and the y values. So like 4 times 21, what does that equal?
oh my goodness. 81.
Sorry.
I mean 84.
Yeah, 84. And then 6 times 14 also equals 84, and so on. Okay. So when the and this is to answer your question, when the product of the numbers is the same, that is inverse variation, but they all have to multiply out. So like 12 times 7 does, 8.4 times 10 does, 8 times 10.5 does also. So if the numbers multiply together and always equal the same thing, then it's inverse variation.
Okay, I'm gonna write that down. And then what about like direct and either?
So direct variation, you would end up dividing the numbers and getting the same ratio each time, but it's y over x, giving you the same ratio, or x over y, I guess. But you're only going to get one question like this on a test. So I would stay away from trying to like memorize this. There are other ways to do this, I guess, because usually the test question is like, write the equation of direct variation, write the inverse variation equation. So if the y over x always is the same number, then it's the direct variation.
Okay.
This one,
and then I'm guessing if they don't
right,
equal any of the same numbers, it's neither.
yes, and that's where you have to test all the points, because if you look at the first one or two and those work but the others don't, that's where a deceptive teacher could get you on a problem. But these are written with software, so I don't think you'll run into that.
Okay.
Okay.
Right.
Go ahead and answer this one, inverse variation, and then let's see if we can do one more before we close out this this lesson.
Okay. So 4 times 21, so it was 20. I mean 84.
And 6 times
14, 84.
Yes. So this one is inverse variation because they multiply together and equal the same thing.
Right. And if should I multiply all of them, or like once it gets like 3 and like 4, I should be like, oh, it's director.
It's like, yes, that should be okay. Should be okay. I want to say for sure, but yeah, I would probably check them all, especially if it was for a grade. Like if it was a test, I would check them all. All right, so we're actually going to go ahead and just stop here. I do a separate booking for each hour, so if you could just reconnect with that other booking in about 10 minutes, and we'll get this done real quick. Thank you, Jayla. See you soon.
Got it. Thank you.
Bye.
See you soon.